Welcome to readmeproject.com. Project title: A Street-Centric Routing Protocol based on Microtopology in Vehicular Ad Hoc Networks. Let's see the abstract. In general, vehicular network has high mobility and the uneven distribution of vehicles, which are important factors that affecting the performance of the routing protocols. The high mobility may cause frequent changes of network topology, whereas the uneven distribution of the vehicles may lead to routing failures due to the network partition. Even high density of vehicles may cause severe wireless channel congestion in an urban environment. In this project, the proposed work uses a novel concept called the microtopology, which consists of the number of vehicles and the wireless links among the vehicles along a street as a basic component of routing paths and even the entire network topology. The MT model reflecting the dynamic routing related characteristics in practical urban scenarios along the streets, including the effect of mobility of vehicles, signal fading, wireless channel congestion, and the existing data traffic. This process analyzes the end-site routing performance in an MT as a basis of the routing decision. Also, the proposed work uses a novel street-centric routing protocol based on the microtopology, which was called as SRPMT. It's consisting of the routing decision and the packet forwarding. The simulation result shows that the proposed system achieves a higher packet delivery rate and the shorter average end-to-end delay compared with the performance of the existing system. Now see the flow diagram. First, the network is formed, which all consists of the number of vehicles. It is declared as a microtopology, that is, the number of wireless links and the relay strategy are included in this microtopology. After that, the inside-to-inside framework is created, that is, the street is divided as the inside-to-inside between the number of vehicles. After that, the SRPMT implementation protocol is processed, which is for finding the routing path of the data transmission of vehicles. It includes the vehicle's GPS, that is, each and every vehicle's position is included in this protocol. After that, it estimates the route. If the route is validated, means it forwards the packet. It is estimated by using the next hop neighbor. If the route is not found, means then it again finding the route by using this protocol. After the packet forwarding, the performance is evaluated, which is the proposed system is compared with the existing system. Let's see the running procedure. To run our coding, first open the terminal window and go to the directory where we have the code. Then type ms space file name .tcl. 30 nodes are created and the coding is running now. This positions is updated for finding the GPS system of vehicles. Here the network coordinator window is open. Here only we see the simulation results. To see the simulation, maximize the window, and these are the structure for the street topology, and the number of vehicles are represented here. To run the simulation, click the play button. Here the vehicles are moving in the street along the roadside, and within this street is considered as the microtopology. Now the packet transmission is processed between the vehicles. The source node generates the packet and it forwards to the destination node by the intermediate nodes, which is done by the routing protocol SRPMT. We can speed up the simulation process All the vehicles are moved along their path and the data communication is transferred using the CPR. Here the CPR packets are transferred here. Now this node transfers to the intermediate node and it again transfers to the intermediate node. Then it reaches the destination node, which are all done by the routing protocol. Now the destination node receives the packet of the source node. This is the intersection phase that one street is connected with the other street that represents the inside-to-inside communication. So this is the representation of inside-to-inside communication, which are all done by the CPU traffic. And for the microtopology, it is done within the street. We can able to see that the intermediate node is forwarded here, passed here, and the packets are transmitted through this node. Here the communication is processed as the microtopology routing strategies in this street. So we see the performance result in the graph. The next is a graph. Here is the graph of the network overhead, which are varied along the time variation. And this is the graph of the delay. The x-axis makes the time unit are represented. The graph is plotted as sending time and the receiving time of each and every packet. And this is the packet average ratio. The number of packets sent or received or not by the user is plotted here. So all the packets are sent between the source and the destination. Hence, the existing system have lower performance than our proposed system.